Okay, this is just an extra video to show you guys a proof of the vertex formula. Okay, and when I'm talking about the vertex formula, what I mean is that x of the vertex is equal to negative b over 2a. So we're going to show where this came from. All right, now what we're going to do to use this, is the general formula. And the general formula for a quadratic equation is y equals ax squared plus bx plus c. All right, now you guys have now learned about vertex form of a parabola, okay? And the vertex form is y equals a x minus p squared plus q, where p is our x vertex and q is our y vertex. Okay, so if we can turn the general form into the vertex form, then we should be able to come up with the x vertex, and hopefully what is here in place of p is going to be the same as what we have up here. So let's give this a go and see what we can do. All right, now in order to go from general form into vertex form, what we always do, as we discussed in the lessons, is completing the square. Okay, now in the new books, we no longer do completing the square for terms where a is not 1, sorry. In this case, we have to allow for any value of a, so it's going to be a little harder than what you guys have done before, but that's not a problem. All right, I'll go through it, we'll explain it, it should be fine. Okay, so first thing we have to do to complete the square here is we need to take a as a factor of those first two terms. Okay, the c is not so important. Okay, so we're going to take firstly y equals a, and then we're going to work out what's going to go in this bracket. Ax squared divided by a is obviously just x squared. Okay, now bx divided by a, there's no a in bx. Okay, so in order to do that, what we're actually going to do is we're going to write bx over a. Okay, all right, and what you can see here is now that the a times b over a will just give us b, which is what we had originally anyway. Okay, plus c. So we're getting a little bit closer. You can see that we now have an a in front of a bracket plus a c, okay? But that bracket needs to be a square term, all right? We want x minus p squared. That's what you can see up the top here, okay? We want to have something similar here. So what we're going to do is we're going to complete the square just for this bracketed area, okay? So we have y equals a brackets x squared plus b over ax. Okay, we know we're going to have to add and subtract something, and then plus c. All right, now how did we remember what we were going to add and subtract? In the past we always did b over 2. In this case b is b over a. I know it's a little bit confusing, we're working with two different b's at the moment. Okay, but we have b over a divided by 2. Okay, now is the same as b over 2a, and if you don't know why that is, then you need to do a little bit more practice with dividing fractions. Okay, and that's something that we will do in a later topic as well. Okay, so we have our b over 2 term. All right, so what we're going to do here is we're going to add that. So we're going to add b over 2a squared, and then we're going to minus b over 2a squared. And you know that the reason we do that is that the net effect is nothing. Okay, we're adding and subtracting the same thing, so we're actually adding 0. All right, this part here is now becoming a nice square. Okay, so we have y equals a. Now we're going to have to use two sets of brackets here because we have something extra going on. So I'm going to use these big square brackets. In the first bracket we have our square, that's the x plus b over 2a squared. All right, then we still have our minus b over 2a squared. Okay, and then we can close, sorry, we had big brackets there, then we can close these square brackets plus c. All right, now at this point we already kind of have our answer, but we should really, to be fair, we should simplify it properly. Okay, So what we can do now is we can expand these big square brackets, okay? And to expand that bracket, all we're going to do is multiply the a by both terms, okay? So we're going to have a brackets x plus b over 2a squared, okay, minus a times b over 2a squared plus c. All right, and then we can just simplify this, okay? So we get a x plus b over 2a squared minus, we're going to have a b squared over 2a squared, which becomes 4a squared plus c, okay, which is a x plus b over 2a squared minus, now one of these a's is going to cancel out, so we end up with b squared over 4a plus c, okay, and that is our formula. Okay, now this is in the form of y equals a x minus p squared plus q, okay, and remember that p was the x vertex, this lovely one here. So this was our x vertex. Okay, and you need to be careful with this one because remember it is the opposite of what we're expecting here. So we're going to get our x vertex. I don't know what is going wrong with my pen today. Our x vertex is equal to the negative of b over 2a. We need to do that in order to get a negative p there. And our y vertex, our q, y vertex is equal to negative b squared over 4a plus c. Now the second one's not important, okay, we don't tend to actually use that. We tend to just use the x vertex because when we have the x vertex we can just substitute that in, okay, but you can see that that's actually what we end up with as our formula, okay, and later on you'll be able to test that out. But for now, this is the proof of how we get that x vertex formula of x vertex is negative b over 2a. Okay.